Okay, we figured it out. We figured it out.
Where we screwed up again?
Yeah, I did, and it was in an embarrassing place. If you know some Java, you were probably screaming at the video when I wrote this line. How did we figure it out? It was interesting, though. So what we did is we tried to simulate in our machine what Heroku was doing,
yeah.
and that was to just run the application,
yeah,
right?
yeah.
And if we just run the application, we don't have an environment variable called port, and we start the application on port 7000.
Yes. So it works here.
So it works on my machine, and it starts on port 7000. Great.
Yes.
Okay, so let's simulate what Heroku is doing by setting an environment variable that I am calling port, and I'm saying that it's running on a different port, like 7001. And then when I run that, I get on my machine exactly the same kind of error that Heroku was getting. And that is a null pointer exception on line 57. Well, we're getting that null pointer exception because of this get integer. That's not how you turn a string into an integer. It's called parse int. And with that, we can stop, restart,
and see if it actually works on 7001.
Yeah, and it does.
It does.
So if we fix that and commit and push, and
it should work.
Now Heroku should be up and working. Fix
system environment variable.
Environment variable parsing of string to integer to fix a problem that happened in Heroku because Leandro made a mistake when initially
Don't write that long commit messages.
This code.
Don't ever.
Oops. Sorry about that. Don't write commit messages like this. Okay. Push. Fix environment variable parsing of string.
That's a long commit message.
Okay, activity, and
go refresh a couple of times.
Wait for this to pick up.
Yes, it's build in progress. We can actually see what's happening now.
Gradle app detected. This is way faster than Travis. I'm happy with Heroku. I've been working with both Heroku and Travis, and when I have to run things in Travis and test things out, I'm like,
I can go get a cup of tea, relax, and come back.
Yeah, but Heroku is fast.
Yeah, except the first time. That's it.
Yeah. Okay, so we will come back to this part, compressing 92.4 megabytes. We'll talk about this later. Remember this part. Okay, so we have deployed the thing, and let's see if it works now. We open the application.
Still slow.
It is slow, but I think it will work.
Fingers crossed. There's no. So can you go back to the build in progress thing? Yeah. See, there's and more logs, I think. Yeah, view logs. So right now it's starting a Gradle daemon.
That it always promises that it will be faster the next time. I think that it will be faster the first time it gets it right and spins up the application and succeeds. And then it will learn to
so the thing
do
with
it faster the next time.
Heroku basically, I don't know what it's called, but it if you don't refresh your page for 30 minutes, it's a stale application.
Yes.
So it has to redo the whole thing. Okay, let's see. There is some problem, but that is...
What problem? Memory?
Memory quota. But I don't think that's a problem.
Yeah, I don't know about that. But the important thing is, first, it started on a different port. So the environment variable was set, and you can check this. Every time the application starts, it may start on a different port. And the application is live.
It actually works.
We did this. Awesome. We can create some to-do items and everything.
Yeah.
And here in the log, we see a lot of calls. A lot of calls. They're all gets. Do you remember why?
Oh, you're asking for those items every 2 seconds.
Every 200 milliseconds. It's 5 times per second. Yeah, don't curse. Yeah, so the application is asking for the list of items every 200 milliseconds. This is a terrible idea, but it's an easy one to implement. The right way of doing this would probably to use a technology called Websockets. And then we could let the server tell that something changed. And then there is a persistent connection between client and server, and the server just sends data when necessary. This is somewhat harder to implement, so we are not doing it now.
It's a lot trickier,
And it's good enough. I mean, look at this. I am now going not to my own machine, but to some other machine, and I don't even know where the Heroku data center is.
And you're still going and getting information.
It's reasonably fast, right? So this
Can you refresh? See, you still have all the items, so it is persistent.
It's not persistent.
Like it's fetching it from different machines or different applications or anything. It is the same thing.
What I call good enough.
Yes.
It is good enough for demonstration
it's a good start.
purposes.
Exactly.
It's like the way we integrated React with our application using the script tags. It's not something it should do, but
it's a good start. Exactly.
So in the logs, it goes crazy. Every 200 milliseconds, there is another request coming in. Okay, that is part one of this story. But I told you that slug size was coming back. And you mentioned this, that if an application is idle for 30 minutes, we run out of memory from time to time. I don't know what it is, but it appears that it's requiring more than 512 megabytes. I think that's how much memory you have in Heroku, and then we are going over it. We'll see. If this becomes a problem, we'll try to figure it out. But for now, it's still working, so I don't know. Anyway, the point is that if your application is idle for 30 minutes, Heroku shuts it down.
Exactly.
And something interesting happens when that occurs. So I will simulate this by, currently the thing is running. I will just turn it off if I can. I don't really remember how to do this. But I think that there is a way for me to shut it down. Okay.
Confirm.
I shut it down, and now if I go to the app...
You still have to confirm shutting it down. Confirm.
Okay. So now the app is down. And this is going to happen after 30 minutes. But if
it's not responding, if you don't send it a request or anything, yes, every 30 minutes.
But the thing is, when you don't shut it down like I did, when someone requests something, they just spin up the application again automatically, which is not happening now because I told it to permanently shut it down. So you get an application error. But then I will restart the application. And the first time when the application is spinning up, it's somewhat slow again. And it's something that happens if you wait 30 minutes and hit the application again. And that's only a problem in the free Linux.
Free tier, because they're trying to supply something that they're not making money out of us. So
but then the application is taking a while to spin up.
Still downloading.
Is it promising that the next time will be faster?
Yes, it will. Go scroll down. I told you.
It's a lie. I don't trust this.
No, the point is that how it actually works is that if it goes stale for 30 minutes, after that it will be faster. In the sense that if you don't force shut it down, it'll be faster there.
I'm not even sure I trust this, but in any case, because I think what's happening is it's creating that slug, that thing with 92 megabytes, and then it's like an image. Anytime we need to restart the app, it restarts from that image, which means that our database file, that DB file, is gone. It's no longer so if you wait 30 minutes and revisit your application, look at that. The database is gone. Again, this is a terrible idea in reality. If you're doing this for real, you don't want this to happen. So the solution
and you won't be using a free tier Heroku Dino to do this.
True. But the thing is, even if you pay Heroku, they don't shut your application down every 30 minutes, but they will refresh the application anytime you deploy. So you would lose your database from deploy to deploy, which is a terrible idea, right? So this is called an ephemeral file system. The file system, the database is in the file system, and the file system starts afresh.
It goes away
frequently. So the solution here is to use another database system called Postgres or some other database system at all. Probably the best one to use is Postgres because it is the SQL in Postgres is similar to the SQL in SQLite. It's not exactly the same. But also Heroku provides Postgres
integration
in the free tier too. They do that. But the problem is you would have to install Postgres on your machine for development, and it can become hard if you don't know what you're doing. And with SQLite,
it's straightforward.
You just install the dependency, and it comes with everything. So it's easier to set up, and that's why we have the SQLite and not Postgres in the toolbox. And that's why deploying SQLite to Heroku is a terrible idea, and why we are doing it nonetheless. Okay.
I like how you say that. But okay, we have something up.
We have deployed the application.
Yes. That officially covers one iteration of the entire toolbox.
Yes.
What if I want another iteration though?
That's a good question, because we have done things in the wrong order.
Yes.
For pedagogical purposes.
Yeah.
We have started with the meat, the interesting part, building an application, seeing it work.
Yeah.
But that's not the entire picture. You don't want to just start coding things. I mean, it's good for a while.
I know people who will disagree with that, but then I'm sure they don't understand their folly.
Yeah, it may be good for a while. It may be good for like a small app.
Yeah. But when you're actually building a system, you need to know what you're doing, what you want to do, what you plan to do, everything from the outset, because all of that will change. Yeah. You need direction, and then you can see where it pivots.
Yeah, in group projects, you may be working with 5 people over the course of one semester, or more people over the course of more
years.
Yeah,
like there are technologies that take years to come out.
So you want to have a plan.
Exactly.
And for the next part of this series, we want to have a plan. So let's build a plan.
Yeah, that sounds good.
Yeah. So in GitHub, there is this thing called a project. And we are going to create a new project that we are calling TODOOSE. And this is going to be for the whole project. But you could have different boards with different purposes, like one for marketing, one for, I don't know.
For that matter, even in development, you can have different boards. Like one can be for your front-end stuff, one can be for your back-end stuff. Might not be the greatest idea considering they're supposed to overlap.
Yeah.
It's still an idea.
Maybe if the groups are separate and you just have, suppose you have a team divided in 3. An API design team, a team to do the front end, and a team to do the back end. That sometimes happens in industry.
Yeah, exactly. So both the back end team will follow the design specifications that the API design team has given strictly, and the front end team will work on the client, assuming that the API design team's specification is exactly what they're getting. So there's no actual overlap except for the blind trust that data will come to me in a specific format.
But because our team is so small, it's only the 2 of us.
Yeah.
I think it's good to have just one board.
Also, if for like a tip for your projects, if you guys decide to do this compartmentalization, you need to enforce very strict data format restrictions, because I have been in this predicament when I was doing client stuff and someone else was doing backend, and I never got data in the same format they promised. Because you can, the thing is, again, we were not thinking of how to actually do this forward. We were just like, let's write code. There was no proper direction.
Yeah.
So you need that specification, you need that design, and you need that vision to actually come through and have it integrated if you have different teams.
It makes perfect sense. You know what? I propose something. Now we are going to develop a plan for the rest of the app.
Yeah.
There are, of course, still features missing. We can edit items. We can mark them as done. So there are still things to do. So develop a plan today. And on the next video, we can write some tests. Executable tests.
Yes.
So we had some tests in previous episodes that were unit tests in JUnit. They were testing one class or one method.
Yeah, exactly. One function.
We can also write tests on a different level. They're still automated tests at the API level.
Yeah.
In Postman,
integration testing.
Exactly.
Yes.
In Postman, we can write tests to make sure that the data format is consistent and makes sense. So these Postman tests are executable, so people can write them and tell, so this is the specification. If the tests are passing and your app is doing something wrong, it's your fault.
Yep.
If the tests are not passing, it's my fault.
Exactly. You have transparency that way. You know what is actually happening.
Yeah. So that's going to be the next episode.
Yeah.
All right, for now, let's add a column that we are calling, I don't know, I think it's iteration 2 now, because iteration 1 was done. So you know what, I'm creating iteration 1, and I'm adding a card to it saying, did this without a plan. Oops.
Fair.
And it was added by me. So you know who to blame. And
oh yeah, GitHub's good that way. You like considering the fact that you have names associated with everything you're doing, and the fact that it's all open, there is enough accountability and transparency there.
Yeah. So for iteration 2,
you can't go blaming, yeah, that guy didn't give me the data. I know what happened. I can check your GitHub repository.
Yeah. So for iteration 2, while we were talking about integration testing in Postman, integration testing with Postman. There is something to be said about the order in which we are doing things here. It's common for people to start the application, what I would say, chronologically. Because if you go to an application, you take your phone and you install an app, or you go to a website, the first thing you do is you create an account.
Yeah.
If it's a system.
So you start from a sign-up page.
Yeah. So you would start developing system in iteration 1 with sign up and login. I would say that's a terrible idea.
Yeah.
Chronologically, it makes sense, but that's not what your app does. It's not what your app is.
Yes.
So I think that the best way to start is with the features. For instance, in our To-Do app, the first thing we did was the API design for getting items, not for creating an item or editing an item. So we just assumed that items would be there.
Available, yeah.
In some cases, we had to hard code some items because we wanted to see them. So we started with the meat.
How stuff is working.
Yeah, we started with the most important. We want to be able to see the items. Suppose that this To-Do app had some logging and sign up. I would still start the same way. So in iteration 1, if you see create login page, you lose.
It's a bad idea. Yeah, exactly.
So you have to think about the things that are more important, not necessarily the ones that come first when using the app. So integration testing in Postman is something we want to do. Another thing we want to do is to
mark items as done.
Mark items
as done. Yes. Edit items, because right now we're adding empty subfields. Okay. Can you think of anything else? We need better code, like better code quality.
Yeah, so
refactoring, reviewing.
Review and refactor. Refactor is to rewrite the code to do exactly the same, but
in a better fashion.
In a better way.
More understandable.
Yeah, so now I
think that's a good enough plan to begin with.
Yeah, I wanted this to be in the order I put them. So integration testing comes first, and this comes last. And in these two, I don't have a preference. Probably want to do this way.
Exactly.
I think it will be simpler to do it this way. Okay.
Let's start by actually creating an issue then.
Yeah, so this is a plan. And we want you to have a plan for your projects, not only for the 2 iterations that we have here. We will probably only have 2 in this small project.
Yes, it's a tiny thing.
Oh, actually, I will create here an iteration 3 that I will probably do off camera. But
documentation?
Yes, write documentation. Why? Well, because this is our README for now. And I think that our students need a little more than that. So I'll probably do this off camera.
The app is pretty self-explanatory. It tells you what it's doing.
Yeah, so we want you to have a plan for the whole thing. But of course, this plan doesn't exactly work out.
Exactly.
So you have flexibility. Suppose that we don't do refactoring here. We just move it here. The important thing is that you keep this idea of how your app is going to progress. And of course, iteration 2, you have a much better idea than iteration 17.
Yes.
But you still have, like, in iteration 17,
far-off thing that
you say,
to deploy to AWS or something like that.
We have reached 1 million customers.
Exactly,
it's time for us to
scale up. Or
it's time for us to move to Postgres because our 1 million customers are losing their data every 30 minutes.
It's time to move off Heroku because you can't serve 1 million customers on a free tier Dino.
Fair. Yeah, it's time to actually put some cash
Yeah,
into the
exactly.
app. Okay,
Stuff like that.
so
Okay.
this is a plan, just
Yeah.
cards. It's like post-its
Yeah.
on a wall. Now let's start working on the first one, right?
Yeah.
So integration testing in Postman is the first one. We are going to convert this into an issue.
Yes.
And we can write some description here if we
Do
need.
we want any description here? I was thinking, do we want like a list of tests or a list that has to be completed for this issue
Fair.
to be done?
So suppose that we have two API endpoints that we want to test. Well, they are the get items and the post items. Yeah. And I believe there are more tests that we need to create here, like IDs are identifiers, as I call them. Identifiers are increment.
Yeah.
And what else? Items start empty. That's another thing.
Yes.
They start with
yes.
start with empty description. That sort of thing.
Yeah. No, but that will be in post, not get.
Okay, as you wish. So yeah, we can have a list of things that need to be done in this test, so we can break it apart.
Exactly.
And this is probably only for people who are working on this issue. If there are people that are not involved in this part of the project, they don't care about this part. Yeah. They will still care about the board with all the plan. Yeah. So we convert this into an issue. And now this, what is this doing? Well, first it's communicating that someone is working on it.
Yeah.
In fact, we can go to the issue now, and we can even say who is working on it. Let's say that I am working on it.
Yeah.
And then my little head appears here.
Yeah.
So now we know who is working on that, and multiple people may be working on the same issue. And we have things to do here, and
so that's where it shows 0 out of 4, yeah.
And you can see how it's progressing. So suppose that we have done this, then it appears here as work in progress. So as a group advisor, I really like this project board, because I can go to a project board and I can see exactly what the group is doing. In like 30 seconds, I have an idea.
Exactly. It makes my life easier if I don't have to go to code and look at how they're doing it or doing whatever.
Yep.
This is much better.
Yeah. So this is an issue. Okay. An issue is like a pull request, except that we don't have any code yet.
Yes.
So an issue
we will try to address an issue in a pull request.
Yes. The pull request will be solving the issue.
Yes.
And yeah, we have some work to do, I guess.
Yeah.
So is there anything else you want to do in terms of planning?
I think this is a good start. Okay. We can obviously modify plans as we go along.
Fair.
That's the point.
But I think this is a good start.
Yeah.
So I see you on the next one when we actually start working
on this one.
on this one.
On this issue. All right.
Bye.